Okay, so the recording just started, so we start. Let me just turn off my video, only leave my voice, so to make sure I concentrate on the slide. Okay, so welcome to the tutorial, and I think you are the e-commerce stream students. So for this teaching week, we discussed the following topics: analysis, design, architecture, implementation, testing, and TDD. And finally, there is a case study, which you apply all the knowledge you learned to do the case study. I do hope the case study can help you to get on your group coursework. So by now, it's the end of your Friday at your side. You should have watched all the videos and completed the exercise yourself. So the purpose of this tutorial today, we go through the model answers, okay, of those exercises. But please make sure that more importantly, you have done this yourself. You have really thought about the solutions, work it out yourself, then come back to watch the video is more helpful. Okay, so during the time, you're free to ask questions from time to time. And if I do ask you some questions, please give some response so I know you're following me, okay? So the first set of questions is analysis and design. Let me see. So I make a hand here. Do you see my hand here moving from somewhere? Do you see that? Do you see on the page there is a small hand moving? Yes, great. Okay, fine. Then that means you see exactly what I do now. So let's go straight to the first question. Describe the relationship between the bank account, current account, junior account, and saving account with a UML class diagram. This question should be really straightforward because this is what we do in our lab too. And also we I introduced this in the case study. So in the case study, it's stated very clearly the difference between the three different types of this account. Okay, so can you just quickly let me know if we're going to describe the relationship between those accounts, what is the name of this relationship? Just one word. Anyone? Type in the chat box. What? Yeah, inheritance. Thanks, Zehua. Brilliant. So this is straightforward because we already discussed this in the case study. So as we can see, the bank account is the parent class, which is to model a normal bank account with account number, account name, and the balance, and blah, blah, blah. So the other three are just the special type of the bank account. So current account, the special things in the current account is we allow overdraft in the current account. Junior account, the only feature in the junior account to be added is that the age limit must be less than 16. And the saving account, the special thing about that itself is you need to give notice if you want to withdraw money. Okay, so to work out this simple relationship, we just need to understand, okay, if something they do exactly the same, we should put it in the parent class. If there is something only for the child class itself, we should put it in the child class. This is just make sure we reuse the existing code and we do not have a duplicate of code at all. So now if I ask you a question, let me see. If I do deposit method, okay? So for this method, where should we put this method to? Which class? Which class shall we write this function? Yeah, there are four classes: bank account, current account, junior account, saving account. If I'm going to write the code of deposit, okay, which class should I do? Any response? Here? Bank. Yeah, the top. You mean if you say bank, I mean you mean you're talking about the control class, maybe talking about, yeah, that's right, Yiping. If we say within these four classes, we should put this in the parent class, because no matter current account, junior account, or saving account, they do the deposit, do this method exactly the same. That's right. If they are exactly the same, we put it into the parent class. So if I say give notice, which class should I put this method to? This is the give notice for 7 days notice for withdrawing the money, for example. So in which class? Yes, saving class, right, exactly. Because this is the only available in the saving class account itself. So current account do not have access to that, junior account do not have access to that, and the parent bank account do not have access to this method, okay? So remember the encapsulation things, every class manage the functions itself. Okay, this is pretty much straightforward. Let's move down to the second question. This is more challenge, okay? I don't know what do you feel when you see this, but this is a commonly seen problem. So first of all, can I ask, right? So this is the user stories. Can you tell me who is responsible for writing user stories? So who is responsible for writing user stories? Give me something. Everyone. Yes, yes, yeah. Everyone in the group, but not only everyone in the group. Even if sometimes you when you get the when you're trying to gather the requirement, yeah, stakeholders. Yes, anybody. Yes, that's right. So when you talk to anyone, even when you do the interview, right? For example, this is just a normal person you met on the street. You do an interview just to ask them how do you use the system. So that's why everyone can write the user story. And this is the collection of what you're finding, okay, through interview, questionnaire, or any kind of fact-finding technologies. So by the end, when you get a piece of user story, it may not be well written. So typically something like that. So let's quickly go through this one. So a digital library system is being developed for Query library, okay? And blah, blah, is used by Query staff, students, and public members, and blah, blah. So that is perhaps the first version of the story you get. So as your role as the business analyst, you have to extract the important information from this user story. So what we first need to try to identify are the entity classes. Okay, so remember, when we see a story, we will, in your mind, you need to think about how do we implement this story into code, right? So what can help you to implement into code is kind of class diagrams. So in your mind, okay, on your paper, then to draw the model, say how many classes are there, are you going to write? Then you can transfer the classes into the Java code. So for the classes, as remember, let's get started from the most basic entity classes, as is to model information, to model long-lived persistent information. So basically, entity classes to model the data. Apart from that, there are boundary classes to model the interaction and control class to do the real work. So for this question, let's first of all work out what are the data we're going to model, what are the entity classes. So the simple way to work this out is as shown in this slide. This is the easier way and the most effective way. You simply highlight the nouns and the verbs in the statement, okay? The nouns could be potentially, as we say, could be a class or an attribute. And the verb could be the method, which is the operation. So initially, when you highlight the things that may not make sense, but we need to, as the business analyst, we should have the ability to extract the essential things and identify through the roles, okay? So if you identify something as an entity class, are they use the system the same way or differently? So if we go back to highlight some entity classes here, we identify that, okay, this is a digital library. It's to be used by Query staff, okay? This potentially is entity, Query students. This is another entity, and public members. Okay, then we keep going. It says some users. Okay, here comes users, and then comes like admin staff, comes to librarians. Okay, let's just look at these few highlighted terms. So if you don't really do analysis, you probably straight away think, okay, there's a class staff, there's a class student, and there's a class called public members, and a class called user, a class called admin staff, a class called library. Perhaps, yes, that's the initial things you come to your mind. You write down, these are the classes, entity classes we have. However, when you do the analysis, we really need to think about in terms of the roles on the system, right? So we need to do the analysis. Here, when we talk about Query staff and the students and other public members, we need to think, are they the same or different? Okay, in this statement, can we tell whether the staff and the students use the system the same way or differently? Right, so this is the question. So from this statement, we can't tell whether staff and the students use the same system any different. So they belongs to the same entity. And sometimes we're using the term public members. It doesn't seem to have any particular differences, right, between the staff, student, and the public members. You can see we use different words or terms to describe the entity in the story because this is a normal person would describe. But from the business analyst point of view, we need to identify whether the staff, student, public member, and the user, and even the admin staff libraries, are they doing this in the same way or differently? Okay, so the key things, first of all, you highlight the candidates, but talking about the role they play in the system, okay? And are they using the system same way or differently? So the key thing is to identify what they play in this system. So in this library system, if we highlight in this class, you can see the yellow highlight is the referred entities, right? And the blue ones are the verbs. The verbs mention about the operation, so it can tell you whether they do the operation the same way or differently. So let's look at what they can do and distinguish the similarity and the differences. So from this statement, we can see read books. Okay, so you can stay in the library and read books. That is the operation. Everybody can do. You can see staff, students, public members say, perhaps this means everybody can go into library and read the book as long as they are the library member. And some of the users can only read but cannot borrow, but others can read and borrow. Okay, so from this statement, we can see there are clearly two different groups of the members. One group of the members can only read in the library but cannot borrow the book. The other group of the members can read and borrow. Okay, so here it tell you the differences between these two groups. Then let's move down. Library admin staff can check in and check out books. So only admin staff can check in and check out. So this is something special. And the librarians can perform all the above duties plus order new books. So here are three new operations: check in, check out, and order. So we can see who can do that, who cannot do that. Okay, so from the operations, we can see no matter staff or students, they use the system when they are in the system. It doesn't matter where they are staff or students. They are all the library member. They are all the library users. Okay, so in this case, it's not sensible to using staff or student as the entity in this system because there's no difference. Instead, we're using the role they play. Remember, go back to the case study in our banking system if you already watched the video, right? There's a customer, which is whoever has the bank account, but there's the role called depositor, right? Depositor can be anyone who pays the money to the account. It doesn't need to be the account holder. It doesn't need to be the customer of this bank. So similar here, we're using the role like depositor, things like that, to identify the entity. So this is the a draft, okay? Perhaps just to show you how do we do that. So as we can see, no matter staff, students, and any other members or users, whatever name they use, the role they play in the library system, they are the library member. Okay, so you can see I put here. The top level entity class is the library member because this is the role they play in the library system. Okay, so for the common features they have, we put in the parent class called library member. So like member ID, the name and email, because these are shared information which every member should have. So we put them into the entity class. Okay, so for the child class, we can clearly identify for the users, there are two groups. One can read, the other one can read and borrow. Okay, so let's make this hierarchy in inheritance. Let's using the name reader, okay, rather than staff, member, student, blah, blah. So reader is to identify those who can stay in the library and read the book. And the method, of course, is read. Okay, so this is the one group of the member can only read. And we know the other member of the groups can read and borrow. So let's use another extent to indicate it's a borrower. So borrower can read, okay, because it's to extend from the reader. So borrower can read, but also can borrow and return book, right? So this is the two features we added to the borrower. So the other group of member they can do as the role they play is to for the administration. Okay, it's not read or borrow book. So the role completely switched to the administration. So for the administrator, okay, who can check in and check out. And what a librarian can do, as we said, a librarian can do all the duties administrator can do, plus can order. So the librarian simply extend from the administrator and only add the order function here. Okay, so I hope this is clear. And this is just the model answer. This, if you work out something else, as long as it makes sense, it's fine. Okay, you don't have to be exactly like this diagram, but it's just to tell you the entity you identified should follow the role they play in the system. And for all the functions they share, the behavior they should put into the higher hierarchy of the classes. For something especially, only the child class have like the order, like the borrow and the return, they should be put in the lower level, the child classes. Okay, I hope this is clear. Can you just let me know? Is that okay? Did you get what I said? Yes or no? Did you get this idea? So this is the way, yeah, why can't administrator read books? Right. Again, this is what we're talking about, the role they play, okay? Okay. So remember, a real person in the library at one time can perform only one role. A real person can be a reader. And the other time when he is taking the head, play the role as administrator, he is the administrator. So they can be the same person. Do you remember? Do you understand? So it can be the same person, but when the person play the role as the reader, he just simply read the book. But when he play the role as the administrator, this person play the role administrator. He only performed administrator role. So these are the roles rather than the real person. A person can have different role. Depends when they log into the system, what role they play, right? So the same as the QM Plus, I can log in as the teacher, right? And also I can log in as a student to see what you see. So for me, I'm the same person, but when I use the system different way, I play different role in the system. Did you get me, Zhehua? Yes. When the administrator logged in the system as the administrator, he's not the reader, okay? But he logged out and logged in as the reader. He's a reader. Yeah. So this is a very important thing I want you to distinguish that the real world person, okay, and the role they play in the system, they are different, okay? The same person can play the different roles in the system. Okay, so that's the key thing I hope you can take away from this exercise. So let's move on to the architecture. This question, the first question, okay, when we talking about architecture, we say the simple way to just to draw the architecture is using box and arrows, right? So using different box, different arrows to show different architecture, no matter it's client server, cloud, and distributed system. So using different notations to on the diagram just to show the architecture is a simple way. So for this question, can you tell me what's the problem with this diagram? What's confusion it can cause? What's the issues there? What is your answer? What do you think about this diagram? Did this diagram bring you any confusion? Do you understand what's this diagram trying to tell you? So first of all, I want to see your answer. Right? Is this diagram clear? State what the architecture is. What's the problem? Any confusion you think? Anyone? Do you have your answer? Okay, so no one write down anything, can I ask you, all right? So you can see here, basically, the diagram want to show you a client server architecture. There's a one server here and 3 clients. They are PC clients and trying to connect to the server. Okay. So you can see client 1 is a rectangle shape. Client 2 is an oval shape and black. Client 3 is another different shape and a gray background. What do you think? Do you think the client 1 and 2 and 3 are the same thing, or they have they different? What do you think? Client 1, 2, 3, are they the same type of client or different type of client? Anyone? Do you think from this diagram, what is the indication? Do you think client 1, 2, 3 are the same or different? Different, right? Yeah, you think it's different because they're using different shape and different background, right? Okay, let's look at the connections. It says data connection, but client 1 using a dot line, client 2 using a dot and arrow line, client 3 using a solid and arrow line. Okay, what do you think? Does this make you think the connection from the 3 clients are different? Do you think the connection showing in different arrow line are same or different? Anyone else has the opinion? Okay. So this is the confusion caused. Okay, the same as the client. You can see for the PC client, they're using client 1, client 2, and client 3, but they only mention these are the PC clients. So this diagram makes us think, okay, client 1, 2, 3 are different because they're using different color and shape. And the same here, say data connections, but using different type of lines. This makes us think the data connection is different. Okay, so you can see on the text here is exactly what I just about to say. The issue here is that in the diagram, if you're using the notation in a different way, they perhaps should mean different meanings, right? Different shape, color, and styles. By common sense, we will think these are meant to be different things. However, if there's no significant difference, if you think they are the same, you should try to using the consistent label or notation, right? If they are all PC clients, but there are no difference, you should use them in all of them in the same color, the same shape. And if all the connections, okay, are the same, you should use all the same type of the arrow and lines. So let's it is, okay? So if you do mean they are different, clear label it why they are different. For example, the client, some maybe the PC client, mobile client, okay, they are clearly different. But if they are all PC clients has no difference, you should try to use the same arrow, the same shape and the color. If the connections, right, like using wired connection or wireless connection, if they are different, yeah, model is differently. If they are the same, you should do the same. Okay, right. Can you just tell me, did you get it? Did you get the answer for this question? Yes, great. Okay, let's move on. We need to hurry up a little bit. So this question 2 is a little bit difficult. And this question is actually a little bit open-ended, okay? So in the lecture of RESTful, we talk about there's an architecture style called REST. Okay, so what is a REST? It's not a new, as we say, it's not a new architecture. It's basically a constraint that your architecture has to satisfy the constraints. There are 5 constraints plus 1 optional. So if I show you the lecture slides here, let's this is extracted from the lecture slides. So RESTful architecture is basically talking about in the client-server architecture, you're using a uniform and a predefined set of stateless operations. So if you read more yourself, and if you listen to the video, you can see stateless basically means you using the normal HTTP protocol, right? So the client does have the session has been recorded, but the server doesn't need to record any session information. So this reduces a lot of burden for the server. So that we call stateless, right? Uniform, which means for all the resources, all the web resources, no matter it's a file or image or different kind of file, the resources, we need to using a uniform way, which means like a URL, like a URI. So like for example, this one, give you a URL is pointed to the resources, okay? So this means we need to be RESTful, we need to use a uniform the way for the web resources, and it should be stateless. So to claim architecture is RESTful, it has to satisfy 6 constraints, but actually the 5. The last one is optional. Okay, code on demand is optional, but you have to meet the 5 constraints. First of all, it needs to be client server, and then cacheability, uniform interface, stateless, okay, layered system. So if you meet all the 5 constraints, you can claim, okay, your architecture is RESTful. Okay, so this is a quick overview on that. So the Twitter API is called Twitter REST API. So it makes you think should be RESTful, which means it should satisfy at least the 5 compulsory constraints. Okay, but there are a lot discussion and evidence. If I don't know if you have opened this or not to really check the Twitter API, and a lot of people argue that the Twitter RESTful API is not really REST. Okay, so I don't know, what do you think? Why we're arguing that the Twitter API is not RESTful? So give you a little bit hint. So there are 5, okay, constraints we need to meet. So which one the Twitter API does not meet? I understand this question is a bit difficult because first of all, you need to understand the overall networking protocol things. But I believe you studied the network telecommunication network protocol and advanced network programming, right? You should have enough knowledge on this kind of web-based structure. So is the Twitter API client server? Yes. Cache? Yes. Right? And what about uniform interface and stateless? So those are the 2 we are questioning. Right? So, okay. I can quickly give you explanation, but so I say, to fully understand this, you need a lot of other knowledge. For example, you understand the HTTP protocol, you need to understand the URL, URI, the basic things. Okay, so why we argue that the Twitter API does not meet the RESTful constraints? Mainly about the uniform interface. Okay, so to claim your API is RESTful, which means you need to using the uniform interface, which means you need to using the URI. If I say, right, URI should directly point to a resource. For example, here, for any of the link, when you click, it pointed to a page or a file. Okay, this is the unified identifier. So URI. So for any of the points, we should directly point to a page or a file. So in the HTTP protocol, you send the request and you directly get the response, which is the result. And it should be stateless because only the client records the session information, the server does not. Okay, so let's say the stateless perhaps using the HTTP protocol is met. However, the URI is not. So this requires you to do a lot of research and reading on the Twitter API. Twitter API using the URI using the RPC lag. If I highlight on that, this is not a direct resource. Okay, it's not a directly give you a web resource. So what directly give you a web resource is something like that. If you point to this this link, this tell you a page directly. This is the page will be returned to you without any process. Also, all of this link is the same. When you click that, it's pointed to a unified resource on the web server. However, in the Twitter API, the URI sometimes give you this kind of RPC lag, right? So this is not a direct resource. This one is kind of command and call. So when you give this kind of URI, there is a process you need to implement. And after the process, you return the result. So it's not a return you the direct resource. So it's not uniform interface, right? So that is the problem to break the uniform interface requirement, because this request will not give you the point directly to the web resource. It requires you to operate some operation at the back end. Okay, so as a summary, for an API to be RESTful, right, the URI needed to be directly pointed to a web resource rather than promote a call, right? So for the Twitter API, it actually make a remote call rather than directly give you the resource. So we probably say it's break the uniform interface requirement for the RESTful. Okay, so there are a lot on this discussion, and it's kind of open-ended because somebody argued that it's not strictly break this constraint. We still can say it RESTful. So this is no right or wrong. This is kind of just a different opinion on that. Okay, so if you're interested, you can read more on this kind of link. Read all the, click all of the resources and check what do they say are RESTful, why and why not you think they think a Twitter API is not truly RESTful. And then there's a lot of interesting discussions if you check on these web resources. Okay, this question I understand is perhaps a bit difficult for you at the moment. Don't worry about this too much. I hope you just basically understand this and do some further readings by yourself. Okay, so did you get it? Can I move on? If not, I will simply just suggest you go to read all the documents we pointed out in this page. Okay, after the tutorial, I will publish this this PDF file, so you can click those links to do more reading. Okay. So for now, I just need you to understand what is the RESTful architecture. You need to make to satisfy the 5 constraints. Okay. Yeah, can I get some response? Did you get it? If not, doesn't matter. You can do more readings after this. Can I move on? Do you have any particular questions here? Anyone? Get it? Okay, great. Thanks, Yang. Okay, let's move on to the testing. Question 1 should be straightforward. Why does software have bugs? Okay, dispatch, we do all sort of tests. Yeah, this is the answer we can write down straight away, because as we say, it's not just simply not possible to test every possible circumstance. Okay, like to test the input value, there are endless of possibilities. We can't possibly test everything. So the best thing we can do is to, within our time and the budget constraint, we choose the best subset of the input data. That's what say we need to create our test cases. So test cases is basically for you to choose the best subset of the input and which is to represent the full range of the possible input data, right? So yeah, if we say a perfect software product should have no bugs, but as we say, it's not possible at all, because we only have certain time, we only have certain budget, and it simply is not possible to test every single possibilities of the input. So all the testing is to create a test case for the subset of the input data and to make sure the software is good enough to be used in the real world for the operational use. So good enough for us to deliver the software product. Of course, when we identify any problems, any bugs later, we can issue new versions to fix that. Okay, so especially in the current situation, as we can see, we urgently need a lot of new applications, like we needed to track the patient, the activities. We need to get the patient numbers reported, and in the market, there's a high demand on the online education application, etc. So we only have very short time frame. So within the short time frame, we can only try to release the software products which is good enough. Then we can keep improving, adding new features and fix bug in the later versions. Okay, so that is basically the answer of question 1. Let's move on to the a practical question about test case design. So this is assume in the theater or whatever cinema for selling the ticket. The ticket full price is £100, and depending on the age, we could give some discount to a certain age group of people. So there is a component in this software system which is to calculate the actual price you need to pay for the ticket after discount. So we asking you to design the test case using partition testing. Okay, right? So you can see when we calculate the discount of the price, there are so many different kind of possible input age, right? It's not possible to test every single one, so we choose the best breed to represent the whole range. So partition testing is the technique can be used in unit testing and integration testing, which is a technique to help you identify the different partitions, or we say classes, in this input range, and help us to choose the input test data, and we can perform the test. So this question is particularly, it's quite typical, and it should be straightforward. So let's have a very quick recap, okay? Understand the partition testing. Partition testing, you need to divide all the possible input and output into different partitions. And they fall into the partition, and for each partition, we should choose the boundary values, right? The boundary values include sometimes upper boundary and the lower boundary, and one mid-range value. So your first task is to divide it into different partitions, and your second task is to choose the typical values from each range for you to do your test. Okay, so let's go back to this table. It's quite clear, right? There are 3 different partitions. Age 26 to 64 is a partition. 6 to 25 is a partition. 65 plus is a partition. And of course, less than 6 is another partition. So I hope you work this out yourself, similar as the example we given in the lecture notes. So here perhaps is the answer, but it's not absolute answer again. So let's look at each of them. For each partition, you need to give the name of this partition. For example, here, partition 1 is the adult age, right? So we need to choose the typical value of the input, boundary values, and mid-range. So for this partition 1, the lower boundary is 26. The upper boundary is 64, right? The mid-range value here, I put 45 here, but you can put anything like 43, 47, 30, doesn't matter. So any value between 26 and 64 is okay, right? Any kind of mid-range value. It doesn't have to be exactly the middle, okay? So for this kind of partition, we say partition 1, we choose 3 values, 26, 64, and 45. And for all of the 3 input, the expected output should be 100 because adult has no discount, so they should pay the full price. So the input we choose and the expected output, we need to write it down. Okay, so for each partition, this is the way you need to write. What's the name of the partition? What are the input value you choose, and what are the expected output? Similar for this partition 2, for the young person. So for the young person, the lower boundary and upper boundary again is clear, 6 and 25. For the middle range, I put 17 here, but again, it doesn't matter. It doesn't have to be exactly in the middle. Any number between 6 to 25 is fine. Okay, so for this range, as we say, they have 20% discount. So the output here should be 80. So for these 3 input, the output should be 80. Partition 3, which is age 65 plus. So here we only have a lower boundary. We don't have an upper boundary. Okay, it's a no limit. However, I mean, we need to make common sense, right? So for the middle range, I choose 80. You can choose any number reasonable, like 70, 75, it's all fine. But we don't tend to choose like 200 or something, right? Because we need to make common sense. This is a typical age we could accept. So for partition 3, we only have a lower boundary, and you choose a reasonable middle range value. So for partition 3 is 10% discount, so the expected output should be 90. Okay, so the 3 partitions 1 to 3 are the one you must have, and you choose the input values and to predict their output. For this partition 4 is something we could do outside of the partition testing, but you can, as optional, you can include that, which is any invalid input. Okay, for example, the age is less than 6 should not be allowed, and any other non-integer, non-digits, negative value, right? So these are the possible input you should consider, but this can be verified before you feed in the actual input to that. So it's up to you whether to have this option. If you don't have this option, you need to make sure your data is already verified before you do your test. So for this kind of invalid input, you should provide a reasonable output. So if the number is less than 6, you should say the age must be over 6. And if for non-integer negative value things, you should say invalid input, something like that. Okay, So I hope this is clear. So the three partitions you need to identify. Yeah. Any questions on that? Is that clear? Can we move on to the coding now? Yeah, can I have some response? Is that okay now? Can I move on to the next question? Yeah, okay, great. Okay, it's pretty much clear. Now let's move on to really test this particular component using TDD. Okay, so TDD again is a difficult topic for your experience. I hope you already watched my demo on the TDD. It's basically to write a test first and demonstrate that the test is failed, and then make the test pass, and then fail, then pass. This kind of a small circle on that. So question one, when we want to test this approach using the partition testing, and we write a test program. So we create the ticket object, which given the full price is 100. Okay, so we use assert equals functions here, and to compare the value. So the key things is how do we use assert equals function, right? Assert equals function require two parameters. The first parameter is the expected output. The second parameter is the actual output, right? So if we compare the expected output, which is the same as the actual output, we pass the test. Otherwise, the test fails. So based on our partition from here, we identify these several input, right? 26, 64, 45, blah, blah. So these are the input we want to test. And we know what are the expected output. So this question should be straightforward. So for the first partition, age 26, 64, 45, the expected output should be 100 because there's full price, okay? For the young person discount, we should test the three values: lower boundary 6, upper boundary 25, and a mid range 17. And for the 10% discount for the older age, we have a lower boundary 65 and any mid range 80. So the expected output should be 90. Right. So now this is the testing code we are going to run. And if we run this code now, it should show us the test failed, right? Because we don't have our ticket class yet. Now we need to produce our ticket class to pass this test. Okay, so yeah, I don't know, have you done it yourself? It's best to do it yourself and actually using the JUnit to see you see the red bar then green bar to pass the test. Okay, this probably quite straightforward, similar as the example we see in the demo. So we create our class ticket, right? So if you look at the test ticket has been created using a new keyword and with the input parameter. The input is the age, and that is the way we create the ticket. So to pass this test, our constructor must follow this. So we have a private double value, which is the full price of this ticket. And to create this ticket, we provide the full price. And we have the function called getPrice, which is to input this age, right? So we can see here is the full price. Here is the getPrice function, input is the age. So we need to create our class like that. This is the constructor, and this is the getPrice with the input is the age, output is the double, which is the value. So here you can see the blue line. I didn't put any code here, but I leave it to yourself. This is to assume we already validate the input before we down to our test. Okay, so we should already validate the input should greater than or equals to 6, must be an integer and greater than or equal to 6. If not, we should throw an exception. So I leave this to you to write the code to validate the input. So the following red code is assumption that the input has already been validated. So clearly we can make this 3 partition. So if the age is within this range, we return 80% discount, otherwise 90% discount, otherwise return the full price. So the 3 partitions has been done there, okay? So remember, you need to finish the code to validate the input before you move on to here. So now if you run this code, you perhaps will see the green bar to really pass the test. Okay, so I hope that is clear to this question. And for the test case, for choosing the input for the test code and then to production code to pass the test. Right, any question? So we are just right on time. Is this clear? I do hope you run the code yourself after this and to really see the green bar to pass the test in the JUnit. Okay. Do you have any more questions? We have 3 minutes left. No? Everything clear about the exercises? You can see this is kind of the exercise you expect, right? In your exam as well. So you need to basically apply those knowledge to solve the problem, like analysis and testing all require you to understand and apply the knowledge. Okay, so you can use this to your group coursework as well. And after this tutorial, I will upload this PDF file on QM Plus, so you can have a look. And this session is also recorded. You can go back to watch the video. Right? So if no more questions, we'll finish this tutorial. Is that okay? Thank you for attending. Yeah, thank you. And do post message board if you have any questions. Okay, so bye for now. Take